Hello, I'm Atindra Chaturvedi. In the previous video, we looked at vSphere 6 Advanced Networking. In this video, we are going to take a look at Network I/O Control version 3 that is available in vSphere 6. Network I/O Control, or NIOC, basically allows us now to define for virtual machines the same kinds of shares, reservations, and limits that we could do for CPU and memory in those virtual machines. We can now do the same thing for network I/O as well. So essentially what we are able to do in network I/O control is to create what I look at almost as lanes or defined reserved bandwidth through which one can channel I/O from virtual machines. We can define our own resource pools, essentially network resource pools. And in these network resource pools, we can assign bandwidth, and then we can connect virtual machines to these resource pools via the DV port groups. So the first step would be to create the resource pools, and then the resource pools would be associated with DV port groups, and then the virtual machines would connect to DV port groups. And basically, when there is contention, that's when the individual limits, shares, reservations, capabilities that have been defined for those virtual machines would actually kick in. So a nice clean way of managing the throughput of networking I/O through the distributed switch. And then later on, once we get to the physical side of the network, the class of service and the differentiated services control point markings that have been put on that traffic then takes over. We are going to now configure the Network I/O Control version 3 in the vSphere distributed switch. So we are now at the vSphere web client. I have created a distributed switch, and it has two port groups. One is called D port group Gold, and the second port group is called D port group Silver. In my DV uplink group, I have 4 uplinks, but only 3 NICs. So uplink 1 has VMNIC 2, uplink 2 has that, nothing in uplink 3, and I have 1 NIC adapter, VMNIC 5, that's in uplink 4. So I have a total of 3 multiplied by 1 gigabit NICs, so a total throughput available of 3 gigabits per second. Now, having created that, let's look at the resource allocation tab where all the action for Network I/O Control version 3 actually happens. So here we are. We have a system traffic display on the right hand side here. It says that Network I/O Control is enabled. It's a version 3 because it's a vSphere distributed switch version 6, and then it has 3 network adapters, and each of them has a minimum link speed of 1 gigabit per second. Out of the total bandwidth that's available through one of those physical adapters, 75% of it is allowed to be distributed. So the maximum allowed reservation is 75 megabits per second, and right now, as you can see, we have not configured any reservation. Let's look at the network pools, network resource pools. So in order to create those network resource pools, we have to set aside bandwidth reservation for virtual machine system traffic first. So we can go into system traffic, or we can click on this link. Let's just keep it simple. We go to system traffic, we click on virtual machine traffic, click on the pencil. You can see the shares are high, so it is a value of 100. A normal share would be 50. So let's reserve 250 megabits per second, and let's also put a limit on the virtual machine system traffic of 250 megabits per second. Okay. Now that we have done that, it is plugging away at this point in time. We then go into network resource pools. Okay, it recognizes that now. Click on this. So we look at system traffic. Virtual machine traffic shares value is still high at 100, but we have now reserved 250 megabits per second, and that shows up as the blue line, which is the configured reservation so far. Configured reservation of 250 megabits per second out of the total reservation possible of 75%, which in this case is 75 megabits per second. 25% always has to remain free by the rules of the game. We have bandwidth available up here. So let's go to our network resource pools and create a resource pool. And we call it network resource pool gold. And we give a reservation quota of this to say, let's make it 300 megabits per second. And let's click on that again, and we'll call this silver. And we will give it a max quota. You can see the max quota came down by 300 from the 750 that we'd allocated earlier. We give that 100 megabits per second. And the first resource pool has been created, and we have to update this. It keeps going back to the main D switch, but that's okay. These are the two resource pools that we have configured. The reservations are 300 megabits and 100 megabits. When I click on this, we see that there are no virtual machines obviously connected to this resource pool. Now, virtual machines are not connected to resource pools. Virtual machines are actually connected to distributed port groups, and that's what we're going to do. But before we do that, we are going to associate the network resource pool silver with the distributed port group silver. And we right click on this, edit settings, and we are going to, instead of network resource pool default, we will connect this to network resource pool silver, and we click OK. We do the same thing for distributed gold, except we will connect it to the new resource pool that we've created of reservation of 300 megabits per second, and we are going to connect that to that resource pool. Okay, so those resource pools have been connected, and now what we need to do, we still obviously don't have any virtual machines, so we will now connect some virtual machines to this. So I go into my virtual machines. I will take this big virtual machine that's really important. That's my NetFlow collector. And I will go to the network adapter and change its network adapter. I will now select the port group gold for this, and I will click OK. I will go to the Ubuntu one, edit settings on that, and I'll do the same thing here as well. I will accept that I will connect it to distributed port group silver, and I will do the same thing for the other remaining Ubuntu machine. This will be connected to silver as well, and I click OK. And we'll head back to the networking. Look at our distributed switch again, the resource allocation tab out there. As you can see, the total quota right now is 400 megabits per second, because we have 300 and 100 adding up to the 400. The maximum we can use is 750 megabits, so we still have 35 megabits per second remaining for anything else that we'd want to do later. But now when we click on Network Resource Pool Gold, we see that the virtual machine is connected to it via the distributed port group Gold. And when we click on this, we see that there are virtual machines. Here we go, connected to it. Those two Ubuntu machines. Each of them have a share value of 50-50 and so on. Now, what we can do is we can actually go to these virtual machines and then define the shares if we want to. And we can show that here. I go into Virtual Machines tab. I will look at the first Ubuntu and I will edit settings on that. I will click on the twisty for this, and you will see that I can set normal shares, which would be 50 to this. normal, high, and custom, right? So high would be 100, low would be 25, and this works in exactly the same way. You add up all the shares, and then that's a divisor, and then each individual share on top of that tells you how much under contention that portion of that resource will be taken, just the same way as it works with memory and with CPU. I have not reserved anything, and I am not giving it any higher limit. It will be constrained essentially by the resource pool. We leave this as normal, and we cancel out of that. Back to that tab again, we look at distributed switch. We look at the reservation quota of 100, so that has been reserved. And then beyond that, it'll obviously, we will edit this. So your reservation quota max is 100 megabits, and that's what it'll basically use. We still have a unused quota of 350 megabits for expansion of traffic as required. Okay, and out of the reason this is 3 gigabits per second is because I have 3 adapters, each of 1 gigabit per second. But of course, the maximum bandwidth that can be utilized by one flow, because the actual session between source and destination IP can only happen through one of those NICs. Really, we are limited to the 1 gigabit per second, although the overall bandwidth is 3 times that much. But for each individual flow, it is the value of the bandwidth of the NIC adapter, which is 1 gigabit. And out of that, virtual machine traffic reservation is 250, as we said earlier, and that is always the first thing that has to be set up. So after setting up the virtual machine traffic reservation, what is then possible to do is to set up the network resource pools. In the network resource pools, we define the reservation quota for that resource pool. We then assign that resource pool to a port group. So we look at the port group, edit settings, and in there we can assign the resource pool. So we assign this to gold and cancel out because it's already assigned to gold. And then basically we can either migrate virtual machines to deep port groups, or do it the simple way as I did, because we only have a few virtual machines here, to just change the network adapter settings for that. So that's basically it for Network IO Control version 3. It is quite easy to configure. Unlike in the version 2 of Network IO Control, where there was a kind of a combination of class of service, Network IO Control, it's been separated out now. So it's rather nice, because now your traffic marking and filtering is done in a separate way. It's really meant for the physical network. So it's been a nice separation of what's required for the physical network in the traffic marking and filtering. And in Network IO Control, you are able to control the IO very, very granularly, both for virtual machine traffic as well for system traffic. So obviously, you can give an NFS traffic higher shares. You can maybe give vMotion traffic lower shares. That's the way you want to do it. And FT obviously should probably get at least the normal, if not the higher value of the shares. So you have the ability to manipulate this very, very easily by simply clicking on the traffic type and then the pencil to edit the resource settings for that traffic. Just another quick look. We have vSphere replication traffic, data protection backup traffic, also now as part of the predefined traffic types that are already configured in the resource allocation tab for Network IO Control version 3 for the vSphere 6 distributed switch. So with that, we've covered the what and whys of Network IO Control, as well as configuring Network IO Control version 3 in the vSphere 6 distributed switch. In the next video, we will look at in depth ESXi 6 command line interface for networking. It should be an enjoyable video, and I look forward to seeing you there.